We have now learned the building blocks of programming: variables, data types, conditionals, loops, arrays, 2D arrays, functions, and debugging. Now we need to connect them. What is the difference between coding and programming? And how do these ideas help us build simulations? Coding is writing instruction in a programming language. Programming is bigger than coding. Programming means solving a problem by designing, coding, testing, debugging, and improving a solution. So coding is part of programming, but programming is the full thinking process. Programming is a process. First, we understand the problem, then we design the solution, then we write the code, then we test it, finally we improve it. A good programmer does not just write code. A good programmer thinks clearly about the whole problem. A simulation is a program that models how something changes over time. Instead of copying the real world perfectly, we simplify it. We choose what to store, we choose the rules, then we let the program run step by step. A simulation needs 4 main pieces. First, state, what exists right now. Second, rules, how things can change. Third, a loop, so the simulation can repeat over time. Fourth, a display, so we can see what changed. A cellular automaton combines everything we learned. The grid is stored in a 2D array. Each cell has a state. Conditionals decide whether a cell changes. Loops visit every cell. Functions organize the update rules. Debugging helps us check whether the simulation behaves correctly. In a simulation, coding is writing lines like, for a row in grid, for cell in row, update cell. But programming means asking bigger questions. What does each cell store? What rules should each cell follow? How do we know the rule works? How do we fix the simulation if it behaves strangely? Simulation debugging starts by comparing what we expected with what actually happened. If a cell changes when it should not, we investigate. We check the rule, we check the neighbors, we check the order of updates, then we fix one thing and test again. When a simulation is large, mistakes are hard to see. So we start small. A tiny grid is easier to understand. If the small version works correctly, then we can scale up to a larger simulation. Everything connects. Variables store information, data types describe the information, conditionals make decisions, loops repeat updates. Arrays and 2D arrays store many values, functions organize the code. Debugging helps us fix mistakes. Together, these ideas help us build simulations. Coding is writing instructions in a programming language. Programming is designing, coding, testing, and improving a solution. A simulation is a program that models how a system changes over time. Now it's your turn. Pick one system you can simulate. Describe its state, rules, loop, and display. Then create one small debugging test that proves your rules are working.